Hello and welcome back to a Boeing Revolution, the number one news source for everything to do with the Boeing company and Elon Musk. And I thought today we could look at the microstations that are going to be prevalent throughout this system that Elon Musk is proposing, the urban loop. We could end up with as many as 2,000 to 3,000 of these microstations in and around LA. Maybe even more if the system expands beyond LA. So it's very important that we look at this. It's a very critical part of the system. Without these microstations, it simply won't work. This is personalized mass transit, so you've got to take people to where they want to go. It's not a case of taking them to a station and then walking for 10 minutes. That's not going to work. That's not how we're going to do things. We're going to take people to within 100, 150 meters, say, of where they need to go. So I thought we could have a look at the basics of this actual system of microstations. So each microstation sits on its own branch line that feeds off the main tunnel. So obviously we're not going to have elevators going down into the main tunnel or main arteries of the system. We're going to have these branch lines that feed out from the main tunnels, where people can get onto the pods and get off the pods and get onto the skates. If you look at the picture below, we have two tunnels. One is connected to the main tunnel and then rejoins it later on. So you come off at 45 degrees and then you rejoin later on once you've left the system. So I think the shaft depth will be about 25 to 35 foot. I don't see it being any more or any less than that. I imagine that the tunnels, the secondary tunnels, won't be that long. I'd imagine maybe 200 meters at the very most, and they will probably be built at a gradient, so they will come up at a 1 in say 20 gradient to the elevators, and then obviously after you've got onto the elevator, come down, you'll go down a ramp, again another 1 in 20 gradient to rejoin the system. That helps with efficiency if you've got gravity assisting you accelerating and deaccelerating. The pods will be summoned on demand via a Boeing company app. It's pretty self-explanatory. You'll have an app on your phone. You will put in your end destination. It will select a station for you nearby and give you GPS coordinates, and you'll just walk there, get on the pod, and then get off exactly where you need to be, which is what we have here, personalised mass transport. It serves people perfectly because it takes them to where they need to go, not near where they need to go, which currently doesn't work. That's why we have the last mile problem, which we've had for the last 80 or so years. So it utilises an elevator system similar to those in multi-storey car parks. Obviously we have multi-storey car parks across the world that are automated, so the technology isn't exactly new. It'll be battery powered and with triple the power. So it will be battery powered in case of a power outage. So that way it's earthquake proof, and it's obviously if there's some kind of problem with the power supply, then it's not going to completely crash the entire system, which is great. So here's a system that operates in Hollywood in the USA. As you can see, it's lifting quite a heavy car there, no problem whatsoever. I'd imagine it would be a modified system that the Boeing company would introduce. So the top speed, I'd imagine between 8 to 10 miles per hour. Obviously the shaft is only going to be about 25 foot deep, so it doesn't really need to go that fast. I'd imagine 8 to 10 miles per hour is more than suffice. So in terms of safety, the shaft area is screened off with movable glass panels, automatic doors, or fixed glass panels and a road barrier. So when we come to look at the pictures or the illustrations that have been provided via the Boeing company, you can see it's quite an open area. That's basically just so you can see what's going on with the pod and the skates. In the real world, I'd imagine you'd have these kind of glass panels to prevent people from falling down. For the actual glass pods, when the glass pods rise to the surface, there will be a doorway that will open, maybe about 8 foot wide, and that'll allow people to get on and off the system. For the actual the car skates, you'll just have a fixed glass panel either side, and then at the front and at the rear you'd have these road barriers which would rise and fall when needed to prevent obviously pedestrians and other cars from driving into the shaft accidentally. And that would be more than suffice. So here we go, here's our illustrations. As you can see, top left we've got the car getting on the skate, pretty simple. You'd need those protections around the actual skate to prevent accidents. You can see the pod in action here, bottom left and bottom right. They are moving a good speed, I'd say, maybe about 10 miles an hour, going up and down. So nothing too complicated about that. You could probably pull something from an existing supplier off the shelf and repurpose it to use on this particular system. So, you know, it looks quite good, looks quite efficient, really nice. So, why are we using microstations? You've got to remember this is personalised mass transport. So it's got to take you to where you want to go from where you are. There's no point walking 10 minutes to a train station, getting on the train and then walking another 10 minutes to work, because then you've lost 20 minutes on top of already a half an hour journey. That's nearly an hour. So already you've lost a lot of time where, you know, you could be in bed or enjoying breakfast or even at work doing a bit of extra, you know, work before the boss comes in, which is a bonus. So while we're using microstations, the construction costs are minimal. The excavation area will be around 20 foot by around 10-11 foot. So it's not a great area. You look at some of these shafts that were sunk for Crossrail. They were like 60-70 foot in diameter. So again, the costs are exponentially higher. So it's a lot cheaper than building 3 or 4 very, very big stations. Instead, you build hundreds of small stations. They take up a very small footprint, less land required, and thus less acquisition costs. Obviously, we're operating in some big cities, so the land itself is quite expensive. So if you can just utilise small parcels of land and have them throughout the system, then that's perfect. So, personalised mass transport, a station on every road. So it would be everywhere and anywhere, all over the city. Every sort of 150 metres, you would have a station. On busy roads, you might have maybe 8 or 9 micro stations. You'd have them all over the place, and you would have them where they're needed. So they would feed the system. Can be built almost anywhere. Yes, they can. They can be built in parks, very easily in parks. Because the advantage of being in a park is there's probably not going to be any surfaces under where you're digging. So it's even cheaper. And also it's not taking up much room. Basements. You could feed a tunnel directly into the basement below a skyscraper, which would be perfect because then you could utilise the existing elevators in that building. And obviously you've got parking bays that run down the side of streets. You know, the land's already there, why not utilise it for these microstations? It avoids pedestrians overcrowding sidewalks and bottlenecks. So if you've got lots and lots and lots of pedestrians getting off the system, maybe in LA you've got nearly 1 million people using the system every day. If they're all disembarking the system at various streets all over the city, then that's going to spread the load. That means you'll have less bottlenecks, less congestion on the sidewalks. Can be integrated into existing buildings fairly simply. I mean, you could start with a brand new building and just drop one of these straight into the basement and have it almost come up to the ground floor or maybe the lower basement, and then people could use the existing elevators, so it's perfect in that sense. There has been some criticism of this methodology by the Boeing company. Now, I watch quite a lot of YouTube, and there's this guy here from a YouTube channel called City Beautiful, which is an absolutely brilliant channel. It talks about mass transit systems, light rail, various means that cities are changing to allow more mass transit to be adopted. And it's a really good channel. However, when he was talking about the Boeing company, I disagreed fundamentally with what he's saying. And the reason I'm disagreeing is because I'm an engineer. I've worked in construction for a good decade or so, so I understand the field. And I think what he's saying is incorrect or based on assumptions, so I'll let you hear what he's got to say.
It's a step in the right direction. Those it's probably a lot easier and cheaper just to dedicate transit-only lanes and use buses like we already have.
No, we don't want buses.
I think it's also interesting that he's admitted that transit should come first, and it might put him on a slippery slope to reinventing subways.
Doubt it.
I think the most challenging component of his scheme is the parking space size stops, which he plans to build by the thousands. Cutting a tunnel through the street where there's electrical, communication, water, and sewer lines will prove to be extremely costly and time-consuming. And
No, that's not true.
It's not true.
no engineering magic will change that. Not to mention the big political hurdle of giving away public space to a private entity. If he needs to cut costs on the project, making fewer stops would probably be the easiest way to do that.
No.
So now you have fewer stops. If you're going through the trouble of building a shaft, why not make it like 2 or 3 parking spaces long? You could build bigger transit vehicles to match and carry more people. So now you have buses. And since you have fewer stops and more people per vehicle, it might make sense to operate them on routes, rather than going from point to point. And you can see where I'm going with this. So...
No. He's obviously someone that supports bus routes and light rail, and although I support those kinds of systems, they've got fundamental drawbacks, and one of them is this last mile problem. And the reason the Boeing company is set up this way with microstations is to eliminate that last mile. It's not that difficult to sink a shaft in a road, and I'll go on to explain why that is from a construction perspective. But what we don't want is huge vehicles underground with hundreds of people, because then it's not feet. You could end up with a huge 50-60 foot vehicle with 5 or 6 people on it, and that's not efficient. What we want is small pods that take a small number of people to exactly where they need to go. And sinking a shaft isn't that difficult. You can avoid utilities quite easily. They're well mapped out on city maps. So obviously the issue that he's bringing up is that we could be hitting services underground, sewers, electrical cables, gas mains, that sort of thing. So the best way to overcome that is to use both a cable avoidance tool, which can identify where these cables and sewer lines are, but also to use a vacuum excavator, because then that lowers the risk of you hitting something. So here's an example of the MTS Dyno, which is a vacuum excavator. Really awesome piece of kit, this. Really excellent. So, as you can see, the vacuum excavator is very useful for that initial stage of the excavation. So you close off the area, you remove the existing surface, the tarmac or the paving stones, and then obviously you want to map out where you believe the services are, utility lines. And then you can use the vacuum excavator to remove loose soil from the surface until you find the actual cable itself, and then you can trace it back to where it runs across the actual excavation, and then you can work around it. So the initial sort of 3 to 4 foot of the excavation you would do using the vacuum excavator. Once you've identified all the services, you could then use more traditional means. And then your next task would be to actually divert those services to move them to the outside of the trench, and then you can build your ring beam. So the next stage would be to sink the concrete shaft. So this would be made of prefabricated concrete sections like the picture top right, that you could prefabricate off-site, probably made specifically by the Boeing company for this project. This is a circular excavation. I anticipate that the actual excavations for the Boeing company will be rectangular. They'd be about, say, 20 to 21 foot long by around 11 to 12 foot wide. once you've used your vacuum excavator, you can use your traditional excavator. Build your segments and build a concrete ring beam in situ, and then you can use hydraulic rams to push the actual concrete segments down as you are undercutting them with the excavator, as per this video. So he's digging down. Here we go, initial excavation. There's the ring beam being poured there. Then you've got your hydraulic rams pushing it down. Push it down to where you need to go, add more segments, bolt them together, push it down, use the traditional excavator for the last bit of it. There you go, and just dig down until you reach the level of the secondary tunnel, and then you can break through. The actual secondary tunnel might already have been dug, so you might just be joining to it. So as you get to that level, you'll reach the top of that tunnel, and then you can obviously break through and then join it up. So I thought just to finish, we'd do a few key questions to sort of identify problems that we've found with this system that can be debunked, because 99% of the problems that have been posed by people on Twitter, people on YouTube are rubbish. Frankly, they have no real understanding of civil engineering, and therefore they're just coming at it from an amateur perspective. So, are some roadworks likely? Yes. There's going to be, probably for the Chicago project, we could end up with in excess of maybe 20 excavations for shafts. So there will be roadworks near these areas. Hopefully before the actual tunnel begins to be bored by the TBMs, you'll know where these need to be, so you'll be able to plan accordingly, set up your roadblocks, find your services, and then conduct the work. But the roadworks will be probably less than 3 to 4 months. Can sewer lines, gas mains, broadband and water mains be diverted, rerouted without causing major disruption? Yes, it is very, very easy. Certainly here in the UK, we have been replacing all our cast iron water mains over the last 40 years very successfully. It has caused a lot of disruption, but I mean, we're talking hundreds of miles of pipes that need to be replaced, cast iron pipes. And in this case, we're talking literally as little as 20 to 22 foot. It'll just be a case of moving the surfaces around the excavation or putting them into the side of the excavation, and then fixing them in place and then digging the rest of your shaft. So it won't cause major disruption, it'll cause some minor disruption. So personalised mass transit or plain old mass transit. Now, the guy from City Beautiful loves his old school mass transit. All these systems that were invented in the 1950s and 1940s. We're past that now. We're on to personalised mass transit. You get into a pod within 100 metres of your house, and then you get off within 100 metres of your office where you work. That's how it should be. And it can be done fairly easily if planned accordingly. And that's what will happen with the Boeing company system. So, are you concerned about safety around the elevator shafts? I am a little bit concerned. However, the problems can be engineered away, and there's already solutions to this. It's not like we need to reinvent the wheel. We can use glass wall panels. We can use existing sort of glass doorways. We can use road barriers. These things have already been used time and time again. So it's not difficult. It's not going to cost an absolute fortune. Let's just put some thought into how we can prevent accidents regarding the shafts. And if we do that, we're not going to have problems. How long will construction take? So a typical shaft, as little as 12 weeks, maybe up to 18 weeks. If we have some issues in regards to moving the actual services. However, as long as we plan in advance and we can identify what services are there, it shouldn't take more than 18 weeks, really. You could probably work around the services for a short period of time. while you dig some of the shaft, and it might just be a case of coming back to it later on and finishing it off. How much is this going to cost? How much is it going to cost to sink a shaft? Difficult to say. The actual concrete segments are prefabricated. They'll be done by Tesla. If you do this in-house, if you've got your own team of people rather than subcontracting it out, I can't see it costing more than, it could be $60,000. Probably cost less than that. That's just being pessimistic. It'll be somewhere between 50 and 8. Let's say $50,000 and $80,000, say, to sink one shaft. Segments are precast. You can use the same guys. It's not a big job. Okay, on a scale of 1 to 10, how easy is sinking a shaft? So 1 being easy, 10 being very, very difficult. Probably like a 3 or a 4. It's not that difficult. It happens all the time. Certainly in the rail industry, civil engineering, quite common. There's people, certainly there'll be people in the USA, in LA, in Chicago who've got experience of that sort of thing. So once you've done it the one time, the next 18, 19 times you do it, it becomes a lot easier. So if you're using the same guys and you do your homework before you dig the shaft, this can be done very quickly. You might even be able to get it down to 10 weeks if you really, get the same guys on it, do your homework. It's fairly easy. So I just thought I'd want to say a big thank you to everyone that subscribed. We're up to 19 subscribers now, which is incredible. More people are joining the actual channel every day. This is great. We're growing the channel. We're going to have more content. I'm going to take the next week off because I've got a few work things to deal with. But after that, hopefully we'll do a Hyperloop video, maybe do some news videos. Hopefully we'll get a bit more news soon, maybe something in regards to the Chicago project. Please like and subscribe. I really appreciate if more people join the channel. If you're new, please subscribe. There's going to be so much content coming over the next year or so. Also, I've got a Twitter channel. I've been posting a bit of news on there, hopefully a few opinions. I'm going to try and tweet Elon Musk, see if I can get a reply at some point. When we get a bit of big news, I'm going to wait for Elon Musk to tweet something and then boom, get in there quick. So, brilliant. Thank you, everyone. Appreciate all the support. It's brilliant. And remember, guys, peace out and don't be boring. Goodbye.